The ocean had a king 190 million years ago, and that creature was just the size of a dolphin. But it still kept everyone else in fear. A fossil collector found its relics in the rock at England's famous Jurassic Coast near a place called Golden Cap in Dorset back in 2001. For centuries before that day, people just walked over it and never noticed this treasure. Then, it traveled all the way to a museum in Ontario, Canada. But it was still there until, in late 2025, scientists realized they weren't looking at just another sea reptile, but at something unique, the only known specimen of its species. The find received a nickname, the sword dragon of Dorset, and got the attention of the scientific world. Ichthyosaurus, the group this animal belongs to, spent their lives in the ocean, but they don't have much in common with fish. Think of them as the marine equivalent of dinosaurs' cousins. For millions of years, they ruled the seas the way sharks and whales dominate today. But the sword dragon didn't have much in common with those bad guys. This creature stretched just about 10 feet long and had a pretty unusual appearance. Many ichthyosaurs had thick skulls and strong jaws, which were just perfect for crushing prey. Instead, evolution gave our guy an incredibly long, narrow snout attached to a high-speed body. Researchers think it used that snout to slash through schools of fish and squid and to stun or slice prey before swallowing it. And the eyes of our sword dragon worked like giant camera lenses. They pulled in every bit of light available, so the animal could see in places where most predators would be almost blind. And in the ocean, where sunlight doesn't travel very far underwater, it's a huge advantage. Fish, squid, and other prey drifted through the gloom, thinking they had some cover from danger, and our dragon could spot them without a problem. It also had a pretty unusual skull. Most animals, including us humans, have a small bone near the nostril area called the lacrimal bone. Normally, it's nothing special. But on the sword dragon, it had odd little prong-like projections sticking out from it, something paleontologists had never seen on any other ichthyosaur before. In paleontology, those tiny details are everything. They become clues that tell scientists they're not looking at a completely new species that lived millions of years ago. The sword dragon skeleton survived in almost perfect shape and preserved its three-dimensional form, not flattened like many other fossils. Scientists even think traces of the creature's last meal still sit inside its remains. So, one moment this animal hunted fish in Jurassic waters, and the next moment it froze in time, with its final lunch locked inside stone for 190 million years. The story got even more interesting once scientists began studying the bones carefully. Some limb bones and teeth have strange deformities, which means the animal suffered injuries or disease while it lived. The skull also has bite marks from a much larger predator, probably another ichthyosaur. That beast likely delivered the final blow. But the biggest reason scientists care about this animal so much is that it fills a massive gap in the fossil record. Fossils from the time period when it lived, around 193 to 184 million years ago, show up very rarely. Before this discovery, paleontologists saw two completely different groups of ichthyosaurs in the fossil record: older ones before this period and newer ones after it. But no one knew exactly when or how that change happened. So, the sword dragon enters the story like a missing puzzle piece. This creature looked more closely related to later species that appeared millions of years afterward. That means the big evolutionary shift in ichthyosaurs likely started earlier than scientists thought. Now, let's leave the ocean and jump to a completely different landscape. One that once baked under the brutal sun of the Sahara. Around 95 million years ago, a predator walked there that looked just as strange as the sword dragon, but it chased prey on land and in rivers instead of the sea. The scientists who led the discovery described this animal as a hell heron. It stretched as long as a school bus and weighed several tons. Its skull had long crocodile-like jaws filled with conical teeth, so it could easily grip slippery fish for lunch. But the really weird part was a crest on its head shaped like a curved blade, a scimitar. It looked so unusual that scientists didn't even recognize the species when they first uncovered the bones in 2019. They only understood what they had after they returned to the site in 2022 and collected more fossils. Researchers find spinosaurs in rocks that formed near ancient coastlines, which clearly shows us that those creatures took their food from the sea. But this one turned up hundreds of miles from any prehistoric sea. The land around it once had forests and rivers instead of desert dunes. That means this giant predator probably went into freshwater ecosystems to look for food there, instead of coastal waters. So it looks like this massive dinosaur was wading through water up to 6.5 feet deep, standing on sturdy legs while scanning the surface for fish. Instead of diving like a crocodile, it likely waited patiently and then snapped its jaws shut in a lightning-fast strike. More than 200 million years ago, another strange survivor swam through freshwater lakes and slow-moving rivers in what is now Zimbabwe, an extinct species of lungfish. Unlike most fish, lungfish can actually breathe air. They have organs that function like primitive lungs, which allows them to gulp oxygen directly from the atmosphere when water becomes too stagnant or low in oxygen. In a way, they live between two worlds, part fish, part early experiment in the transition toward land animals. And that superpower makes lungfish really important to scientists. They are the closest living relatives to the ancient ancestors of all four-limbed animals. There used to be a gap in our knowledge of these creatures, but the new discovery helped fill it. Now we know that many lungfish may be more closely related than they used to think, and scientists can now better understand how these creatures survived for hundreds of millions of years. In a way, lungfish are one of evolution's masterpieces. This ancient blueprint kept working when entire worlds of species were born and vanished around them. Now let's travel even further back in time, way before dinosaurs ruled the planet. Around 275 million years ago, another bizarre creature swam through freshwater lakes in what is now Brazil. Researchers discovered the species from 9 fossilized lower jaws, each about 6 inches long. Instead of pointing upward like normal teeth, this creature's teeth stuck out sideways. Every single jaw had the same strange design, which proved the twist wasn't a mistake, but the way the animal evolved. The inside surface of the jaw had tiny tooth-like bumps called denticles. These structures formed a grinding surface, so the creature had its own built-in food processor. Scientists think it used that unusual mouth to chew small invertebrates, or maybe even plant material. That's a pretty unusual diet for an animal whose close relatives were mostly carnivores. And speaking of its family, this bizarre creature belonged to an extremely ancient lineage called stem tetrapods. Those were early four-limbed vertebrates that gave rise to modern reptiles, birds, mammals, and amphibians. By the time Tankia lived, most of those early lineages had already disappeared. Yet this one somehow survived, and newer, more modern animals evolved around it. Scientists call this kind of animal a living fossil. When researchers analyzed the fossils, they made the conclusion that this mysterious creature grew up to about 3 feet long and probably resembled a salamander with a longer snout. It swam through lakes in a world where the continents still formed the giant supercontinent Gondwana. This discovery is also important because it helps scientists understand how ancient ecosystems functioned and which animals filled different roles in those early communities. The Sahara Desert is home to highly dangerous creatures like the Death Stalker scorpion and the desert horned viper, but they're nothing compared to a mysterious beast that lived there 95 million years ago. Scientists just found a new dinosaur species in the Sahara Desert of Niger. His official name is Spinosaurus mirabilis, and let's just say you wouldn't want to cross paths with him. This beast was as long as a school bus and weighed several tons. He was a massive, powerful predator. His whole body was built to hunt. He used a trap-like jaw to catch the largest fish prehistoric Africa had to offer. His bottom teeth actually poked outward, fitting perfectly between his top teeth to create a tight grip. Once those jaws closed and trapped fish, they couldn't get away. His name, mirabilis, actually means astonishing in Latin. And that's because this dinosaur was a showstopper. He had a really flashy, weird feature. A tall, I mean really tall, crest on his head. It was so big, the researchers actually had to go back to the site and gather more pieces just to make sense of it. Today, it's all just bones, but the team thinks that when he was alive, that crest was brightly colored. It curved up toward the sky like a glowing blade. And being that flashy had one main goal: to attract mates. It worked just like peacocks with their long, bright tails. It's all about showing off for their love interests. At least, that's what researchers think. This discovery is huge because it's only the second Spinosaurus species we've ever found, like the one that starred in Jurassic Park 3. These guys were among the biggest terrestrial carnivores of the late Cretaceous period. That is, meat-eating dinosaurs that lived about 100 to 66 million years ago. They were as huge and fierce as the famous T-Rex. For a long time, most people thought Spinosaurus were aquatic hunters, and we pictured this fierce monster stalking the shore or diving deep to hunt. Some research even suggests their long spines on the tail were basically built-in flippers. But that's not what most scientists believe anymore. New studies show that while the paddle-like tail looks great for swimming, it didn't actually have much muscle. It turns out those tails were likely just for show, kind of like a lizard tail. They just didn't have the power to push such a massive creature through the water. The density of their bones didn't help either. The bottom line is, they wouldn't have been terrible swimmers. They were super slow and couldn't really dive. To give you an idea, if we put this dinosaur next to a crocodile in a pool for a swimming competition, the crocodile would win every single time. Whether they were swimmers or not, scientists seem to agree on one thing: these guys loved the sea. Most of their fossils were found along the North African coast. But then, the mirabilis species showed up and totally changed the game. These were found in the Sahara, where there isn't a drop of water in sight today. Back then, this spot was about 300 to 600 miles away from the nearest ocean. So what's the story here? Is this actually a Spinosaurus? Well, it sure is. And the way scientists actually tracked it down in the middle of the desert is pretty interesting. Because for over 70 years, the main clue was right there, easy to find, but everyone missed it. Back in the 1950s, some French geologists were out in the desert looking for uranium. While they were searching, they stumbled upon these massive bones poking out of the sand at a place called Gadufawa. Nearby at another spot called Acarazeras, a geologist named Hugues Faure found a different fossil site. He found teeth that looked a lot like the ones from a Carcharodontosaurus, which was a massive carnivorous dinosaur. He wrote down one single line about it in his notes, and that was basically it. For some reason that nobody can explain, those notes just sat there. No one took them seriously or even bothered to go back to that site for decades. It wasn't until 2019 that a team led by Paul Sereno from the University of Chicago decided to finally follow that old lead. They basically turned it into a high-stakes treasure hunt. They headed out there, and a local Tuareg man led Sereno's team on motorbikes deep into the Sahara. He took them to a site called Jengwebe, where he remembered seeing fossilized bones a long time ago. Because it was such a long trek back to their main camp, the team didn't have much time. They could only grab a few fossils, mostly teeth and pieces of jawbones, before they had to leave. At that moment, they had no idea they were holding a brand new species in their hands. The team finally headed back there in 2022, and this time, they found even more fossils. That's when they finally put together the 40-foot-long find. And then they were able to confirm three big things. First, this new creature had a really tall and unusual crest on its head. Second, the way the teeth were set was a bit different from its famous relatives. And then we come to the biggest difference of all. For the first time ever, we're seeing a Spinosaurus that lived far from the ocean. But that raises a big question. How did it eat fish? Scientists have a theory. All those bones were found buried in the sediments of an ancient river. That means this dinosaur probably hunted for fish in shallow water. It was big and strong enough to wade into water over 6 feet deep, but it probably spent most of its time in shallow water, just waiting for a big fish to swim by. But if it didn't feel like sushi dinner, it could just wander through the woods and pluck something else to eat. Okay, so you're probably a little confused right now. I'm talking about forests and rivers. But wasn't this thing found in the middle of a desert? Well, the thing is, the Sahara looked completely different back then. It was actually green. The whole landscape was full of rivers and forests while these dinosaurs were roaming around. So that pretty much solves that mystery. But there are still plenty of other questions about this species, like how big they actually were. See, the problem is that the bones we found belonged to a young dinosaur, not a full-grown adult. Estimates say that the creature was probably about 26 feet long when he lost his life, but he could have grown a whole lot bigger than that. That leads us to the second mystery. Because this dinosaur was so huge and looked so unique, scientists have been arguing for years about how much time it actually spent in the water. One theory is that they went through 3 big evolutionary phases. First, way back in the Jurassic period, they started developing these long, crocodile-like snouts. They were perfect for catching fish. Second, during the early Cretaceous, they really started running the show. They moved toward the sea and became the top predators along the ancient coastlines. The final phase happened right as the Atlantic Ocean was opening up. This is when they reached their record-breaking size. They basically became shallow water ambush specialists, sticking mostly to North Africa and South America. But their reign didn't last forever. Around 95 million years ago, there were abrupt changes in the climate and the sea levels increased a lot. Basically, that affected the habitat they lived in, pushing them to the brink. Eventually, their story came to an end. Unfortunately, these new fossils are only part of the puzzle. We still don't know the whole story about Spinosaurus. There might even be other species out there just waiting to be discovered. And to really understand these mysterious giants, we'll have to wait until we find more complete skeletons out in the field.
Now, thousands of years ago, the Sahara Desert was a green valley with rivers, lakes, flowers, various animals, and people who had different DNA. They weren't visitors from another planet or some unknown separate species. In fact, they were quite normal, but their genetic code changed scientists' understanding of how human civilization developed. It sounds a little confusing, but let's start at the beginning. Among the endless dunes of the Sahara, there is a small rock shelter where wanderers can hide from the scorching sun. This place is called Takakori. Recently, it became famous because scientists found 2 mummies there who lived about 7,000 years ago. At that time, in China, people were learning to domesticate pigs. In Egypt, paintings with geometric patterns appeared. Almost everywhere in the world, people were developing agriculture. But what was happening in the Sahara? Scientists analyzed fragments of DNA from the mummies, along with other artifacts found in the cave. They discovered that the bodies belonged to female pastoralists. They lived during a time when the famous desert was known as the Green Sahara because of its humid climate and abundant vegetation. Those mummies belonged to a group of people of unknown origin. Their DNA did not contain the genes typically found in populations that lived in that region. In fact, their genome did not resemble any other known genetic lineage. Surely, there must have been relatives of these people living in other regions. A similar genetic code was found in the remains of hunter-gatherers in the Tafaralt cave located in Morocco. The DNA of the people from these 2 caves was equally distant from the DNA of people who lived in the southern part of the Sahara. Since their DNA was not similar to other genomes in the region, this tribe must have lived quite separately. They probably did not accept strangers and did not move from place to place. They simply didn't need to, since the Green Sahara had everything necessary for life: a good climate, water, and food. These Takakori people lived within their own community as if they were separate from everyone else. But then, how did they learn about animal husbandry? Today, breeding bulls, goats, and other animals seems completely natural, but in the distant past, it was a real breakthrough. Farming and cattle breeding technologies developed around the world during mass migrations. Imagine a small indigenous group living in the Green Sahara. Suddenly, thousands of outsiders who know agricultural techniques arrive from other regions. They take over the land, drive some locals away, allow others to stay, impose their own rules, and begin cultivating the soil. Their settlement grows, and then they migrate to another area where they spread their technologies again. That's how progress developed in the past, at least that is what scientists thought. Of course, during these migrations, different people mixed with each other, which introduced great diversity into the genetic code. But in the case of the Takakori tribe, there was no diversity. They were not attacked, and large-scale migrations did not affect them in any way. So the question arises, how did they know about cattle breeding? This is what surprised researchers. We were convinced that agriculture spread exclusively because of large-scale migrations. The discovered mummies showed scientists that people simply exchanged knowledge and culture. Perhaps a traveler came to the Takakori settlement, showed them how to breed animals, and left. No genetic mixing occurred, which is why they retained a distinct and separate genetic code. It's also possible that someone from Takakori traveled elsewhere and returned with new knowledge about herding. No one conquered anyone. No one imposed their knowledge or rules. In other words, they did what modern people do. They shared experience and knowledge. This small detail in the genome of the two mummies shows that the ancient world may not have been as cruel and harsh as we once imagined. In a sense, the genetic material inside those mummies tells the story of how the technological and cultural development of humankind has changed over time. But there's also the reverse situation, when the development and progress of human civilization shape our genome. What? It sounds strange. Do microwave ovens affect our DNA or something like that? No, it's much bigger than that. Our DNA was changed by fire. If you look at us through the eyes of nature, we are very strange creatures because of our weird relationship with one of the most dangerous elements in the world. But what's so strange about it? Well, just look at nature. Did you see how people in thrillers about wildlife scare away wolves and bears with fire? It's because it really may work, since many animals are afraid of fire and stay away from it. Some lizards learn how to survive wildfires by hiding in already burned bushes, places where the fire will not return. Evolution has made nearly all living creatures avoid fire, but not humans. We're the only species on the planet that does not run from fire but uses it. No other animals live under a constant risk of burns. Evolution was not prepared for this and had to rapidly adjust our genes to match our behavior. The technology of controlling fire is one of the oldest in the world. We used it to keep warm in cold climates, cook food, produce metal and ceramic objects, build homes, and conquer territories. We put hot food into our mouths and drink hot tea. We're the only creatures on the planet that voluntarily put a potentially dangerous source of heat into our mouths. And this has been happening for thousands of years. Fire is still an essential tool, and all this time, we've been getting burned. No other species on Earth experiences anything close to the number of fire-related damages that humans do. And it's not just about our past. Even today, we interact with burning gas stoves, red-hot car radiators, and boiling water in kettles and saucepans. What about risky equipment in factories? The danger has not disappeared. Surely every person has had a small accident with something extremely hot. I know I have. As a result, through evolution, we developed a unique genome unlike that of any other living being. When we touch something hot and our body begins to heal the damaged part, it feels like a natural ability. But this healing depends on specific genetic mechanisms. Without them, even a small accident could cause serious problems. The development of these genetic adaptations was a complex and lengthy process, since changes in DNA do not happen quickly. While humanity was adapting to fire, intense natural selection was taking place. Some scientists even suggest that we are descendants of those who recovered from burns more quickly than others. Of course, mammals also have adaptations related to fire. Scientists studying primate DNA discovered a set of 94 genes that activate in response to burns. So, what makes us different? In humans, some of these genes evolved much faster and became far more effective at healing and fighting bacteria. So, does it turn out that we have a superpower we never realized we had? Yes, but there's bad news. The same immune response that allows us to heal quickly from burns can also cause serious problems. How is that possible? Well, instead of using examples with real people, let us imagine a mannequin with the same fire-related adaptations as a human. When the mannequin receives a small burn, say from a hot radiator under a car hood, its immune system quickly triggers inflammation, during which immune cells neutralize the damage. It is an aggressive healing strategy, but it works. However, if the mannequin gets a large area burn, that same defense becomes dangerous. The immune system uses the same tactic for major burns as it does for minor ones, creating massive inflammation that can be life-threatening. Why is that? Because evolution developed protection against small incidents around a campfire, but not against massive fires. Interestingly, how do scientists explain our craving for extreme sports and adrenaline? What does our DNA say about this? Well, it's a whole new story. Do you like pink? Then this video is for you. But there will be no pink ponies, pink handbags, or pink mini pigs here. Instead, we're going to talk about the pink side of Antarctica. Yeah, this icy continent is not always white. In some places, it turns pink for very strange reasons. Let's take a tour of the pinkest places in Antarctica and uncover their secrets. Antarctica is home to many high mountains and volcanoes that hide all kinds of mysteries. One of them is pink rock. In West Antarctica, among the peaks of the Hudson Mountains, large boulders covered in a pink pigment lie scattered across the landscape. They've puzzled scientists for decades. These stones are made of granite. The pinkish hue of this rock is given by a mineral called feldspar. Pink granite can be found in many places around the world. But why are these rocks sitting among high mountains? Logically, you might assume they broke off from nearby peaks. But the problem is that the mountains themselves have no pink shade at all, which means someone or something removed these rocks from a large granite body and brought them here. But then, where is that massive block of granite? Well, scientists asked themselves the same question and launched a large-scale investigation. First, they analyzed the pink rocks and discovered that they formed about 175 million years ago, during the Jurassic period, when tyrannosaurs were walking the Earth. Hey, I wasn't around then. Well, what if some big, strong dinosaur simply dragged them here because it liked the color? It's a funny theory, but there has to be something else. Scientists decided to fly over the Hudson Mountains in a research aircraft equipped with unique geological sensors. Using special instruments and aerial surveys, they carried out precise gravity measurements and detected a geological signal beneath the Pine Island Glacier. The signal came from a massive granite body roughly half the size of Wales. Okay, now we know where the rocks came from. But how did it happen that gigantic granite deposits ended up beneath a glacier while these stones were scattered across mountain peaks? Well, tens of thousands of years ago, during the last ice age, the glacier in this region was much thicker than it is today. Millions of tons of solid ice pressed down on the granite below. The pressure was so intense that large chunks broke off from the massive pink rock and were pushed high into the mountains. But wait a minute, how is that even possible? A giant glacier presses down on a giant block of granite and somehow squeezes rocks out into mountain peaks? Well, first of all, a glacier is frozen water. In some places, it can melt and seep into cracks in the rock. When it freezes again, it expands and splits the rock apart. Second, glaciers move very slowly over tens and hundreds of thousands of years. A glacier grinds across the granite with its enormous weight, breaking it apart and pushing the smaller fragments along. And those small pink pieces are exactly what scientists found. It's like sandpaper moving across the surface of a wooden beam and scattering shavings in different directions. But why does this matter? Scientists can now better understand how glaciers move and change, and how they interact with the rock beneath them. Most importantly, they can see how Antarctica is changing as global temperatures rise. This helps us predict future climate changes on our planet. Now, let's come down from the high mountains and walk across the crunching snow. The white surface reflects sunlight and blinds you. You search for a darker spot to give your eyes a break, and suddenly you notice a large pink patch. It looks as if someone ate a watermelon here and spilled all the juice onto the snow. This phenomenon is called watermelon snow, but it has nothing to do with the fruit. The unique color is caused by a special type of algae called this. Hey, you try to pronounce this. Right now, these algae appear pink or red because they are in a dormant state. During their reproductive stage, they turn green. When you walk through a park and see yellow and brown leaves, you know it's autumn and the trees are preparing for winter. In Antarctica, instead of yellow leaves, there are pink algae. They turn red as they prepare for the long cold winter, and turn green again as the seasons change. But why do they do this? Well, the change in color helps them survive. White snow reflects sunlight and heat, but pink or green shades reduce reflectivity. The surface absorbs more heat, causing the snow to melt, and the more snow melts, the more water the algae receive. But are water and sunlight really enough for algae to live? Well, of course not. They also need nutrients. But how do they get them? The continent's residents provide the nutrients, and these residents are penguins. These adorable animals go to the bathroom, and their droppings fertilize the snow. Even a tiny amount of dust from penguin poo is enough to supply the algae with the nutrients they need. Now, scientists believe that in the future, pink snow will become much more widespread across Antarctica as temperatures continue to rise. So, if you ever find yourself on this continent with friends and spot pink snow, you can show off your knowledge and explain the science behind it. However, if someone feels tempted to taste the watermelon snow, don't let them. The snow may look like fruit sorbet, but the algae in it are toxic. And don't forget, it also contains particles of penguin doo-doo. So, pink rocks have a pale shade. Watermelon snow has a brighter pink. The colors are getting more intense. And our next phenomenon is hard even to call pink. It has a dark red tone and looks a little eerie. Just look at this. Red water pours out of a glacier, staining everything around it with an ominous color. It's been flowing here for hundreds and possibly even thousands of years. When researchers first noticed this waterfall in the early 20th century, they were shocked. For a long time, no one understood the nature of this phenomenon. People speculated why red water was flowing out of the glacier and what gave it that color. Was it even water? The imagination runs wild. But relax, it really is water. And it isn't actually red. It's transparent, just like the water that flows from our taps. It simply contains something special that changes color upon contact with oxygen and sunlight. Now think about what happens to iron when it gets wet. It oxidizes, forms rust, and turns reddish-brown. Roughly the same process happens here. The water inside the glacier contains a huge amount of iron. When it flows out and comes into contact with oxygen, it oxidizes and takes on this eerie color. This explanation seemed perfect, and scientists were confident in it until they discovered something more. They studied samples of the water and found iron-rich nanospheres. Now, nanospheres are tiny particles, about 100 times smaller than a human red blood cell. In addition to iron, the nanospheres from the waterfall also contain calcium, silicon, aluminum, and sodium. When these nanospheres come into contact with oxygen, they turn red. But where do these nanospheres come from? And why don't we find anything like this in the bottled water we drink? Well, this Antarctic water has been trapped inside the glacier for hundreds of thousands, maybe even millions of years. In a way, it exists outside our planet's atmosphere in unique conditions. There's no light, no air, and everything is cold. Who knows what kinds of microorganisms live there and how they affect the water? Many things could be producing nanospheres and enriching the water with them. Scientists study this waterfall not only to solve its mystery. They believe that if life can exist under such extreme conditions in Antarctica, it might also exist in similar environments on other planets. There are cold, sealed caves without sunlight and oxygen on Mars. What if microorganisms live there too? By studying the phenomena like this on Earth, we can better prepare for future research missions to Mars. So, some scientists drilled through the seafloor off the U.S. East Coast only to find more water. But this time, it's the kind of water we can actually drink. And that's a big deal, because this new freshwater reservoir could supply a metropolis the size of New York City for the next 800 years. Now, the team is confused. They're trying to figure out how a giant freshwater system ended up under the ocean, and more importantly, how it stayed hidden from us for over 20,000 years. Okay, to be fair, scientists have suspected there's fresh water under the seafloor since the late 1960s. But only recently, researchers actually got on a boat to follow up on those reports. They named the mission Expedition 501, and they had one goal: drill to the bottom of the ocean and see what was really hiding down there. So those scientists drilled about 1,300 feet down off the coast of Massachusetts, and once they got that deep, they hit a thick layer of sediment that was basically soaked with fresh water. Now, that freshwater layer sat below this saltier sediment, and above it, there was a tight lid made of clay and silt, material that doesn't really let water pass through. This seal is strong enough to keep the two layers separated. So, up top, you got seawater, and down below, fresh water. The drilling process took about 3 months. In that time, they pulled up 13,200 gallons of water from 3 different spots beneath the seafloor, just off Nantucket and Martha's Vineyard. They're still analyzing the results, but early reports suggest this reservoir might be much bigger than they previously thought. It could stretch from offshore New Jersey all the way north to Maine. Now, despite its size, it did a pretty good job hiding from us. Now, scientists are trying to figure out when and how this reservoir was formed. And back in 2003, one study suggested fresh water could get trapped under the ocean in at least 3 different ways. Theory number 1: tall mountains near the ocean can funnel rainwater straight down from higher elevations and into the seabed. Theory number 2: a hidden reservoir can form if sea levels stay very low for a long time and rainwater seeps into the ground. Then, when sea levels rise again over hundreds of thousands of years, that fresh water can get trapped in the sediment underneath. And theory number 3, which is connected to the one before, is that a freshwater reservoir can form under the ocean when ice sheets grow and sea levels drop. At the bottom of the ice sheet, the ice slides over solid rock, known as bedrock. As the ice scrapes and grinds against this rock, it creates heat, which melts some of the ice. That melted water collects at the base of the ice sheet. Then, because the ice is extremely heavy, it pushes the water down into the ground. Over time, the water gets trapped under layers of sediment. Well, more than 20 years later, scientists are finally close to an answer. The mountain theory is basically ruled out here because of the geography of New England. There are no large high mountain ranges right next to the coast. But the glacier theory could make sense. Their hypothesis is that the fresh water in this reservoir came from glaciers at some point during the last ice age, which lasted from about 2.6 million to 11,000 years ago. Still, it's not a final answer. The team is now studying the reservoir in much more detail. They're still analyzing things like microbes, rare earth elements, and the pore space in the sediment. All of that can help researchers estimate the reservoir's size more precisely. The age of the sediments can also narrow down when exactly it formed, and knowing its origin will help reveal how those systems have evolved over time. We just have to wait a little longer. But one thing is certain, there really is fresh water under the ocean. And when you think about that, it's hard not to wonder, wouldn't some salt get mixed in? And yeah, that can happen. So let's take a look at the map. Here's the reservoir. The farther you go from the coast, the saltier the water gets, and that doesn't matter much to us because it's not safe to drink anyway. But the closer you get to the coast, the less salt there is. The drill site closest to Nantucket and Martha's Vineyard showed that out of every 1,000 parts of water, only 1 part is salt, so it's considered safe. You can drink it, cook with it, and take a bath in it. But why does all of this actually matter? Well, because fresh water is becoming a big problem around the world. I mean, the lack of it. A new United Nations report talks about a global water bankruptcy. They say we've hit a new and pretty worrying stage. More and more river basins and underground water sources, called aquifers, can't go back to their historical normal. Droughts and shortages are becoming more permanent, completely changing what life looks like in some places. For example, the Aral Sea. This was once the world's 3rd largest lake and looked like this back in the 1980s. And this is how it looks today. It's completely dried out. It's not just there. More than half of the world's large lakes have lost water since the early 1990s. And Central Europe has lost 39% of its glacier ice in little over 20 years. So even now, over 1 billion people around the world still don't have access to fresh water. And estimates say that in just 5 years, demand will be 40% higher than supply. That's why this finding is such a huge deal. It doesn't mean we're about to start pumping water from under the ocean tomorrow. But it does mean we might have backup options in the future, especially for big coastal cities. That's exactly the goal of Expedition 501. And it's not just in the U.S. This group is part of a much larger international science program called the International Ocean Discovery Program, or IODP. Their goal is basically to drill deep into the seafloor to understand how Earth works, its climate, its geology, and in this case, its hidden water systems. This expedition came after decades of unanswered questions. Like we mentioned earlier, researchers had hints of fresh water under the seafloor for decades. Those hints came from strange electromagnetic signals and seismic data. But back then, the technology just wasn't good enough to confirm it. So the idea stayed on paper for a long time. Everything changed when modern drilling came into play. Expedition 501 literally drills straight down through the seafloor and pulls up sediment samples. And this process normally takes days to months. Is it safe, though? Well, they say the ship that carries the drilling rig follows international rules to protect the environment. They're also taking every precaution to make sure no solid or liquid material is dumped into the sea during the work. Their new finding off the East Coast is only the beginning. For now, it's the largest one of its kind. But scientists believe there may be still many hidden reservoirs out there around the world. Similar expeditions are planned or already happening near other parts of the world. Soon, scientists might find new reservoirs off the coasts of Indonesia, Australia, and even South Africa. So, Expedition 501 is basically about mapping these hidden freshwater reservoirs and finding out how they form, how stable they are, and whether we can protect them. Because, yeah, they still have a huge technical problem ahead, which is making sure the fresh water doesn't mix with the salty water above and below it. And that really matters if we ever want to use this water in the future, or avoid contaminating aquifers that already exist near the coast. So this expedition is pushing scientists to find answers to a pretty uncomfortable question. If fresh water gets harder and harder to find, what options do we really have left?
Something strange is happening in Egypt's desert. Giant, mysterious green circles are popping up everywhere, hundreds of them. And then you've got dozens of canals and roads connecting into something that looks like a river. But it's not exactly that. This is the ambitious New Delta project, and it has one controversial goal: to flood the desert. It's easy to see why. More than 90% of Egypt is desert, miles and miles of sand dunes and dry land under scorching heat. Almost nothing can grow there. So today, there are basically only two areas where Egypt can grow large amounts of food: the Nile Valley and the Nile Delta. Together, they cover only about 5% of the country's land, but their crops feed about 99% of Egyptians, and that's becoming a real problem because Egypt's population keeps growing. By 2050, estimates say their population will grow by about 40 million people, reaching nearly 160 million. The Nile Valley and the Nile Delta just won't be enough to handle that kind of demand. See the problem here, right? The population is growing, people need more food, but most of the country is desert and there's not much room for new farms. So what can they do? The easy solution is the same one you use when your fridge is empty. You order in. Egypt does that too. They buy huge amounts of food from other countries. But importing food is expensive and time-consuming, so they need to create more space for farms. And they need it fast. That's where the New Delta project comes in. This is a massive agricultural plan meant to turn parts of the desert into green fields. The idea is to move water and farming west of the Nile, and if it works, it could expand Egypt's farmland by about 15%. Sounds great on paper, right? But in reality, this plan comes with a lot of controversy. Their idea is to create an artificial river right in the middle of the desert, about 70 miles long. To make it work, they're building tons of roads and canals to support it. And those strange green circles I mentioned earlier are irrigation systems. They pull water up from wells or pipelines, then slowly spin around and spray water in a big circle over the crops. Okay, so we've got this huge artificial river being built in the middle of the desert, but where is all that water coming from? Well, it comes from three main sources. The first, and by far the biggest, is treated wastewater. They take used water, the kind that goes down sinks and toilets in our homes, for example, and clean it up so it can be used safely again. To do that, they had to build a modern treatment plant in El Hammam, a town in Egypt's northern coast west of Alexandria. Its construction was completed in 2023, and it's absolutely massive. It's so big that it now holds the world record as the largest wastewater treatment plant in the world. It cleans an enormous amount of water every day, enough to fill about 3,000 Olympic-sized swimming pools, and most of that water goes straight to farming. The second source of water comes from the Nile. Basically, they're taking water from Egypt's most famous river, sending it through massive canals and pushing it deep into the desert, into this new, man-made river. Finally, the third source is deep fossil groundwater. In other words, it's water from way under the desert. Down there is something called the Nubian Sandstone Aquifer, basically a huge underground reserve of water that's been trapped for thousands of years. And this is where the controversy starts. It's true that there's a lot of water under the Western Desert, but it's limited. Because this is fossil water, I mean, it's so old that it doesn't really get replaced. Once you pump it out, it won't refill anytime soon, not in our lifetime, and probably not even for many generations. On top of that, the deeper you drill, the saltier the water can get, and we don't want that. You see, most crops don't like salt. If the water is too salty, plants grow slower, give smaller harvests, or dry out. And when you keep watering with salty water, salt builds up in the soil. The water evaporates, but the salt stays. Over time, the land can turn hard, dry, and basically useless for farming. So pumping groundwater might help in the short term, but it raises a big question. Is this really doable in the long run? And there are other concerns too. The project was sold as a big win. Grow more food, create more jobs, and help Egyptians. It also boosts the economy because they're growing expensive fruits and vegetables that get sold abroad to places like Canada, Australia, and Japan. But that's also the problem. Many people complain that the project is mostly about growing crops to sell abroad. And sure, exports bring money into the country, in the big picture, but that doesn't necessarily mean food gets cheaper at home, or that poorer families can afford more. Because even though it has boosted exports, it hasn't done much to prevent massive food price inflation inside the country. So, Egypt's food security problem still isn't fully solved. Many Egyptians are still dealing with high prices and tight budgets. Another controversial thing is that no one knows how much this project actually costs. The press sometimes mentions $5.2 billion, but some experts put the total closer to $9.7 billion. Just the wastewater treatment part alone is said to cost more than $500 million, but it's very hard to know for sure. Journalists and researchers say there isn't much transparency, and the project's finances are tough to track. Experts also warn that farming in the desert is crazy expensive. Unlike the rich soil in the Nile Valley, the western desert is mostly dry sand with very few nutrients. So if you want to grow anything out there, you need tons of irrigation just to make the land workable. And powering all those irrigation systems takes a ton of energy, making farming in the desert even more expensive. Even if you already have a giant artificial river to help you out. Still, some people argue the risks and the costs are worth it, and that things are starting to change. Take wheat, for example. For years, Egypt has been the #1 wheat importer in the world, and that's not exactly a title you want to win, because it costs the country billions of dollars every year. So then the new Delta project comes along, and wheat becomes one of their main targets. Egyptian authorities say it helped them cut wheat imports by 17% in 2025. That saved them around $250 million. This was such a big achievement that the world now has a new #1 wheat importer, China. And it's not just wheat. Oranges, potatoes, grapes. Agriculture is booming over there. According to estimates, food exports jumped from 5 million tons in 2020 to over 8 million tons in 2024. That's why we can say the new Delta project is already changing Egypt's agriculture. And from satellite images, you can see it's changing what the country looks like too, turning dry desert into bright green patches. It's real, and the transformation is pretty dramatic. So there's no doubt this project is both an impressive engineering achievement and a huge experiment. But researchers say it's still too early to know if it will actually solve Egypt's food problem. In the end, it all depends on water, energy costs, and who gets to make the big decisions. If the Nile, treated wastewater, and fossil groundwater can be managed in a sustainable way, the project could seriously boost farming. And if not, it could drain precious water, make the gap between rich and poor even bigger, and leave behind an expensive footprint on the desert. Thanks to sci-fi, we usually imagine extraterrestrials as smart beings with huge heads walking on 2 legs. But if life really exists out there, it could look like, well, anything. From an upside-down nightmare to a weird water creature looking like it was drawn by a toddler. But we don't need to travel across the universe, just back in time. Because a long time ago, Earth already had a creature like that. This is the story of the Tully monster, one of the most bizarre creatures that scientists still can't explain. Around 310 million years ago, Earth was a drastically different place. Today, our continents are scattered like pieces of a broken plate, but back then, during the Carboniferous period, the planet had one supercontinent, Pangaea. That was more than 200 million years before a T-Rex was chasing down a Triceratops. Huge areas were covered in warm, shallow seas and swampy coastlines, with thicker air and higher oxygen levels. Oceans were filled with creatures that never made it past evolution's experimental phase, like this little guy. At one point, the area that's now Illinois was just shallow coastal waters and muddy shores. Sediment from rivers often buried marine creatures, and sometimes trapped them in iron-rich nodules before they could rot away. That's how soft-bodied animals, which usually don't leave fossils, were preserved in detail at a spot known as Mason Creek. Every single Tully monster fossil we know of comes from this one place. It's entirely possible that these strange creatures were swimming all over the prehistoric world. But this could be the only graveyard that had the needed chemistry to preserve their bodies until we found them. But wait, what exactly is this thing? Well, first off, it was named after Francis Tully, the Illinois fossil collector who first found it and brought it to scientists. And second, it wasn't a monster, that's for sure. The animal was pretty small, usually only about 3 to 14 inches long. It had a soft, swimming torso shaped like a thick worm or a slug without any hard shells or bones. But its front end was both the coolest and the weirdest part. It had a long, flexible nozzle sticking out of its face, almost like a vacuum hose, except at the end of that hose was something resembling a claw. The snout itself wasn't rigid, it could extend and bend, similar to how an elephant uses its trunk, or how an octopus reaches with an arm. So instead of biting prey directly, it probably reached out with its face tentacle, grabbed a snack, and pulled it in. Its eyes were another weird, one-of-a-kind feature. They were positioned on a stiff horizontal bar extending from its head, with one eye at each end. This setup gave it a wild field of view, similar to how a periscope or side-mounted cameras can help you see more. Most animals fall into two groups, vertebrates and invertebrates. Vertebrates have a backbone like fish, dinosaurs, dogs, and us humans. Invertebrates don't, like worms, snails, and insects. The Tully monster is one of the rare cases where scientists still argue what it was. When scientists look at the fossils, they see a pale stripe running down the middle of the body. One group says that's just a gut line, which would put the Tully monster in the squishy invertebrate camp, meaning it was a weird swimming slug. But another group claims that it was a notochord, a kind of primitive stiffening rod that evolves into a spine. If they're right, that would make the creature a vertebrate, a distant cousin of fish and even us. Basically, all of this makes the Tully monster a mix of a fish, a worm, and a crab, something never found since. Based on that soft, squishy body and little stabilizer fins, we know the Tully monster wasn't exactly racing other fish. It wasn't fast like a shark. It was more of a slow-motion cruiser. It probably drifted through the water using that long snout to poke around in the mud for jellyfish, sea cucumbers, or maybe even some rotting stuff. Despite its scary-looking claw and eyes, we can't tell for sure if it was a predator. The Tully monster was pretty well adjusted, so we don't know why it went away. If we look at the fossil record, this creature had disappeared way before the massive extinction events wiped out the dinosaurs or the earlier marine life. There wasn't an asteroid or a volcano involved. Perhaps it vanished because its home wasn't the same anymore. Remember, the Carboniferous period was a wet, swampy world. But as time went on, Earth's climate shifted. Tropical estuaries dried up and the chemistry of the water changed. This probably caused Tully's specific playground to disappear. As far as we know, the monster left no genetic heir. Usually, if an animal goes extinct, it leaves behind a cousin or a descendant that evolves into something else. Dinosaurs left us birds. Ancient fish left us, well, modern fish. But the Tully monster remains unique. There's nothing alive today that looks remotely like it. And that's exactly why scientists are still pulling their hair out trying to classify it. We aren't confused because we're missing the pieces. In fact, we have over 2,000 fossils. We're confused because we have nothing to compare it to. And who knows, oceans are largely unexplored, so we might run into some new creature eventually that will add new pieces to the evolutionary puzzle. The Tully monster might be the captain among the weird prehistoric swimmers, but it definitely wasn't alone. If we look back at the fossil record, especially during the Cambrian and Permian periods, we'll find a whole gallery of evolutionary experiments that look like they were designed by a committee of ETs. For example, we had hallucigenia, our upside-down creature. When scientists first found fossils of this tiny worm-like creature, they didn't know which side was up. On one side of its body, they saw long, sharp spines. On the other, they saw soft, stubby protrusions. They assumed the tough parts were legs and the soft protrusions were tentacles on the animal's back. Years later, better fossils revealed it was actually the other way around. The whole animal was put together upside down. The spines were like defensive spikes sticking up, and the softer parts were actually short legs meant to touch the ground. In other words, it wasn't walking on stilts at all. It had been upside down the whole time. Then there was Opabinia. This thing looks like a shrimp that got extremely confused. Most animals are happy with 2 eyes. Spiders have 8, but Opabinia decided it needed 5 for some reason. 5 mushroom-shaped eyes found out on its head, giving it a 360-degree view of the world. And if that wasn't enough, it had a long, flexible nozzle sticking out of its face, kind of like that of the Tully monster. When this animal was first presented at a science conference in the 1970s, the room actually erupted in laughter because everyone thought it was a practical joke. Finally, there was a creature called Helicoprion. At first glance, it looks like a shark. But look at the mouth. Instead of a normal jaw that opens and closes like a hinge, it had something called a tooth whorl. As it grew new teeth, the old ones rotated inward, creating a literal spiral of teeth in its lower jaw. It looked like a circular saw blade embedded in its chin. Scientists spent decades arguing about where this saw blade actually went. Some put it on the nose, some on the tail, until they finally realized it was inside the mouth. All of these creatures, the Tully monster, the upside-down worm, the 5-eyed shrimp, and the buzzsaw shark, remind us of one thing. We think we know what life looks like, but the history of our own planet proves that biology can be stranger than any sci-fi movie. We shouldn't assume evolution follows a straight line toward normal animals like us. Sometimes it takes a detour into the Twilight Zone.